In this video, we're going to demonstrate how to use the cold form export tool here to automatically take the X locations that are on your cold form parts, such as purlins and girts, jambs, and headers, and writes those X locations into a data.txt file that can be automatically imported into your CNC machine rather than the operator inputting that data from a shop drawing or from a report manually. Now, this cold form export tool uses the variables that have been developed by Tekla that are the US PEB custom variables, and you can download this from the Tekla warehouse and install it on your computer and each user that's going to use this tool. And what those US PEB variables do is they do the actual hard work of reading where the whole X locations are on the web, the top, and the bottom flange of cold form parts, and it outputs that as a string variable that I can actually parse through. And this shows some of the data type or different types of outputs that it can do: feet and inches, decimal inches, etc. So what I'm doing is I'm calling those variables with the Tekla API, and I'm just going to format that into the data text file that's going to be required by the machine. We're going to first run a report that uses those US PEB variables that can be generated in human readable form as a PDF report. So I'll select on this and I'll say create from all, and then here within a few seconds it's going to read through the model and it'll open up a PDF and it'll segregate all of the different profiles and show me the X locations on the web, the top, and the bottom flange. And then it also gives me the length. So this has all the information that the machine operator needs, but we want to eliminate the machine operator from having to read this report and manually type anything into a spreadsheet or type anything into the machine control software. We want to digitize this and send it directly to the machine. Okay, so to do the export, we'll come over here to the Applications and Components panel on the right-hand side of Tekla. We'll go underneath the KTS Tools group, and we'll double-click on the Cold Form Export tool icon. That will then launch the tool. Now, there's one option in the dialog box, and you can choose to include parts that have drawings or not. Now, what does that mean? If you had any welded clips, or if you had like a notch or non-standard hole locations and patterns on any of the cold form parts, then you probably need to make a shop drawing of that. So that way the machine operator knows what they need to do manually outside of what the machine can do, or use a custom punch location that's outside of the scope of this automated tool. Now, with that being said, if I go to the document manager, you can see that I've got these two drawings here created just as an example. And if I highlight those, you'll see that those are in the model. So the tool should actually report out that, hey, whether I include these parts in the automated data text file or not, it's still going to warn me and tell me that, hey, there are parts that have drawings created for it. So that way I know as the detailer, I need to make sure I tell the shop what they need to pay attention to. That's outside of the automated scope of this data text file export. Now in this particular example, I'm going to uncheck that, so that way any pieces that have drawings made will not be included in this export. Now the next thing to explain is that we want to make sure that numbering is up to date. So you're going to want to make sure that all of the cold form that you're exporting has its numbering up to date and doesn't have any question marks in the piece marks. And the tool will search and scan for that on each of the cold form parts. If the numbering is not up to date, it will warn you and show that in the log, so that way you can see that and make sure that it is up to date. And you want to make sure that's up to date so that way your quantities and all your data and information being exported is correct. The last thing to explain before we do the export is the no hole bolts or any bad holes that have been input here. So what do I mean? If I actually zoom in here, you're going to see that MBS and slide rule will actually separate the holes from the bolts on a lot of the cold form parts due to the position of how the clip is put in versus where the hole locations are on the girts and the purlins. So if I click on this bolt here, you're going to see over on the right hand side that the special hole is checked and that the no hole option is chosen. So if I inquire on this bolt, you'll see that the bolt is attached to the clip and to the girt, but it actually has no hole going through there. So if I hide this, you're going to see that there's a hole underneath there. And so what MBS and slide rule is doing is it's putting in 3 or 4 separate bolt groups, 2 holes, one for each girt or purlin if there's a lap, and then a hole in or bolt in the clip itself with the bolts turned off, because you can see here in the bolt assembly that's turned off. And then it does the last thing here to actually get the bolt quantity correct. It'll put a bolt in here with the no hole. Now, because this bolt is still like on those parts, you actually will see a bolt callout mark on a shop drawing if you made a cold form assembly shop drawing for this girt. But we don't want that to be output as a hole location in our automated export. The US PEB variables actually take care of this, and they specifically ignore any no-hole bolts. And only holes or bolts that have holes in the actual part are going to be output, and any no-hole bolts should be ignored. Now, one other thing that sometimes happens is if detailers have put in holes or bolts where the second point picked to place that bolt is not beyond the start offset here, then you can actually create an error on the bolt where it can't be modified, and the US PEB variables will actually return a -1 on that for the punch codes and stuff like that. So I'm actually checking to see if that happens. It looks like this model doesn't have any of that, but I have seen a couple models where that is in there. And so if that does happen, you may see that bad hole error or bad hole input in the log file when we run the tool. All right, so there we go. Those are all the special conditions that we needed to explain. Let's go ahead and run the export. Okay, so now I'm going to go ahead and run the export, and I'll press the export parts button here on the tool with nothing selected in the model. You'll see a counter or progress bar here at the lower left. And then once it's done, it's going to open up the log file report. So let's start with that. So I had two pieces here that had drawings created with them. And so I'm not going to include those in the export, which is what I chose up here. But if I click on that, it'll actually highlight that in the model. Now, if I hold down the Z key on my keyboard and then I press on that, it'll actually highlight it and zoom me to that location. So if you have really short headers or like girt parts and things like that, you can easily find them on a really large model. And then that way you can kind of see exactly what should have a drawing created versus what's going to be in the export. Now, once that's all set, we can actually go in here and take a look at the export data itself. Okay, so we're all done with the cold form export tool, so we'll close that down. And then you're going to see that the tool creates a cold form subfolder inside of the Tekla model folder. Then inside of that, there's additional subfolders here that are prefixed with the job number dash the profile. So what I do is, due to the limitation of how the machine control software works, it's looking for the file to be called data.txt. And so basically in each of these folders, I have a data.txt file, but it only contains the specific profiles that are similar to each other. So that way only those will be then run on the same batch on the machine. Now also because the operator will potentially run the same profile across multiple jobs to optimize that run, then they may import multiple data text files from different jobs. And so that's why the job number is here as well. Okay, so let's go ahead and investigate the contents of the files. All right, so let's actually start with this 8-inch deep C16 gauge profile, and we'll open up the data text file here in Notepad. I'll then turn off the word wrap, and you can see that this is pretty much just a tab delimited file. And so up here in the header, the way that this works is that each one of these represent a different piece mark that's going to be run. And then I can tell it the quantity of those piece marks, the length in decimal inches. And then here I've got the job number, and then I've got the profile, and then I've got the piece mark all delimited here inside of this for that particular piece record. So that way the operator out in the shop, if he's doing a run again across multiple jobs, he can see all the information he needs to make sure that this is the right stuff that's going on that run, and then segregate like a DJ2 for door jam 2 that might be on this job compared to another job for when they actually pull these pieces off the machine after they've been run. Then after that, we can see that there are these three codes here which represent which punch die on the machine that's actually being used. So this would be web holes here, and the count of those. This would be flange holes, and it's going to be doing a hole on the top and the bottom flange. And the quantity of those, there's 0 on this particular case. And then the third one would be the C punch pattern here in the file, which is for unique punches or non-standard, which is outside of the scope of this tool. So just going down, this QT1 is going to be any of these A punches, and these are just the X locations. Then down here on the B, that's going to be the flange holes, and then C again would be the custom holes, which we are not going to be doing in this particular case, and the operator would have to look on the drawings to input those if needed. All right, so then here we've got the X locations, and that looks pretty standard. 1.75" to the first hole, that looks pretty common. And it looks like then there's holes on the other end of the part along the length. And if we look at the 146 and we subtract some of these numbers out, that looks about right. So there we go. We have all the information we need. Let's close this down and we'll go to the other one. Now inside of this text file, again, we'll just turn to Word to wrap off. And you can see that there's a lot more parts in here and a lot more hole locations on this. And so again, all the information is needed here, and it's using the US PEB variables to take those hole locations and put it in here. But we're just taking the Tekla API, reading those variables, and then writing it into this data text file that can be imported into the machine automatically to save a lot of re-input time for the operator.